Okay guys, so today I'm going to talk to you about the kinematics equations. Go a quick review about them first. Kinematics equations, something you've probably used in physics class, I know we have. It describes and represents the motion of objects. Actually, they also can be called the big four, so you guys might know them as that. Sorry, my voice goes a little bit there. The first one of these equations is VI plus AT equals VF. I'm just going to go over all of them here. The next one is VF squared equals VI squared plus 2AD. The next one would be D equals VIT plus 1/2 AT squared. And our last one is again D equals 1/2 bracket VI plus VF bracket T. So those are our big four. Using them, if we're dealing with uniform motion, we can, depending on the variables we have, we can solve for the other variable, depending on which formula we choose to use. Another thing you guys might remember is we can't use these if there's a change in acceleration, then we have to break it down into two parts. But once again, that should be a review. Anyway, back to my point. I am going to be going over this because I want to show you how we derived this formula right here. So how it came to be. So, let's do this over here. You guys all know, or I'm hoping you know, the formula for acceleration. So let's start there. Acceleration is equal to velocity over time, right? Pretty simple? Okay, I guess I should do in this. Over here. Okay, acceleration is equal to velocity over time. Another way to write that is acceleration is equal to the change in velocity over the change in time. Now, we can write change by doing the final minus the initial. So let's do that. Acceleration equals velocity final minus velocity initial over change in time. So it's starting to look a little bit more like that, right? We have our four different variables. So our next step would be to multiply the time over. So multiply this by the change in time, multiply this by the change in time. This is again just our normal math. We're just multiplying both things by the same. So now we have acceleration times the change in time is equal to VF minus VI. Now, in order to get that formula to look like this one that we have up here, all we have to do is add VI. Add VI, and here we go. We have acceleration, change in time, plus VI equals VF. That is the exact same as that formula, so I'll write it out in the exact same way. We're going to move this, switch this to this side. VI, actually, you know what? I'll show it to you even more one step. So take away all those funny letters. AT plus VI equals VF. And to put it back into our original one, we're going to switch these two around. VI plus AT equals VF. Velocity initial plus acceleration multiplied by times equals your velocity final. That is our first of our kinematics equation, and that is how that kinematics equation came to be.